Quantum computing. Hype versus reality. When will it truly change the world? In the world of technology, few topics have generated as much excitement, curiosity, and confusion as quantum computing. Some call it the next industrial revolution. Others say it's overhyped and still years away from making a real difference. So, what's the truth? Is quantum computing just another flashy buzzword, or will it truly change the world? Let's break it down simply. First, what exactly is quantum computing? Unlike regular computers that use bits, tiny switches that can be either 0 or 1, quantum computers use qubits. These qubits can exist in multiple states at once, thanks to the strange rules of quantum physics. Imagine flipping a coin. A classical computer sees heads or tails. But a quantum computer sees heads, tails, and every possibility in between, all at once. This concept is called superposition. Another key principle is entanglement, where qubits become linked, and changing one instantly affects the other, no matter how far apart they are. These unusual properties give quantum computers their potential power, at least in theory. The hype around quantum computing started decades ago. Scientists predicted that quantum computers could solve certain problems in seconds that would take today's most powerful supercomputers millions of years. That's why governments, tech giants, and investors have poured billions into quantum research. Google, IBM, Microsoft, Amazon, and startups like Rigetti and IonQ are racing to build practical quantum machines. Even countries like China, the US, and the EU see quantum computing as a top priority. But here's the reality check. Building a usable quantum computer is incredibly hard. Qubits are fragile. They can lose their quantum state due to the slightest noise, heat, or vibration. This problem is called decoherence. To keep qubits stable, quantum computers often need to operate near absolute zero, colder than outer space. Even then, errors are common. Scientists are working on quantum error correction, but it requires thousands of physical qubits to create a single reliable, logical qubit. That means we are still far from the large-scale, fault-tolerant quantum computers needed to solve real-world problems. Despite the challenges, there has been progress. In 2019, Google announced it achieved quantum supremacy. Their 53-qubit computer solved a specific mathematical problem faster than the world's top supercomputer. But critics argue that the problem was impractical and had no real-world use. IBM, on the other hand, is developing quantum computers with over 100 qubits and aims to reach 1,000-qubit machines soon. Yet, even these devices are mostly for research and experimentation, not for tasks that affect our daily lives. So, when will quantum computing truly change the world? The honest answer is, not yet, but eventually. Experts predict that within the next 5 to 15 years, we may see quantum computers capable of solving practical problems in fields like drug discovery, materials science, cryptography, and complex simulations. For example, quantum computers could help design new medicines by simulating how molecules interact, something classical computers struggle with. They might also break current encryption methods, forcing the world to adopt quantum-safe cryptography. In finance, quantum computing could optimize complex portfolios or simulate market behavior. In logistics, it might find the most efficient delivery routes in seconds. But these breakthroughs depend on achieving stable, error-corrected quantum computers with millions of reliable qubits, a massive engineering challenge still underway. Meanwhile, some researchers explore quantum-inspired algorithms that run on classical computers but borrow ideas from quantum physics. These are already providing practical benefits in areas like supply chain optimization and machine learning without needing a full quantum machine. In short, the current state of quantum computing is a mix of excitement, progress, and technical hurdles. The hype is real, but so are the limitations. Like the early days of classical computing or artificial intelligence, we are still laying the foundation. Just as it took decades for computers to evolve from room-sized machines to smartphones, quantum computing will take time. For now, it's important to stay curious but realistic. Quantum computing will likely not replace your laptop anytime soon, but behind the scenes, it could quietly revolutionize industries over the coming decades. So, While the quantum future isn't here yet, research is steadily pushing us closer. The bottom line? Quantum computing is not magic, it's science. And like all great scientific work, it requires patience, persistence, and steady progress, not just hype. When the technology matures, it may indeed change the world. But until then, we must separate flashy headlines from grounded reality, like subscribe.